So basically, what we learned from chapter 2 is the basic. So now we take the advantage of the things we learned. We apply to real life. In reality, in chapter 2, you look at the homework, they are related with real life. And couple one, we want to remind you on the chapter 2 homework. One homework is homework number 49. Homework 49 from the Chinese elementary school or junior high school standard. That is the arithmetic, junior high or 7th grade or 6th grade problem. But we want you to using algebra and using the chapter 2 information to solving that problem. No more arithmetic. So please don't using 6th grade method to solving number 49. You can using graph, you can use equation. Some students using graph, the velocity versus t and velocity versus distance, and plotting the distance, and then you see the graph right away, very nicely. So the number 49 is one problem, is regarding about 2 persons running the race. Now this is one of my favorite problem for the first midterm, but I don't know if I will give to you or not yet. The second very interesting problem for chapter 2 homework is number 57. 57 strictly is a calculus problem. They call derivative problem. A lot of students look at that. They don't know what to do. Actually, it's a math calculus problem. So 57 is a straightforward calculus problem. If you want me to give you a hint, just an L squared equals x squared plus a y squared. And then you do the derivative and you got it. And the student have this one on the midterm, the first midterm. Will you be 50% or 60% student stay, doesn't know what to do. And usually they lost a point here. So now we go to chapter 3. Now the chapter 2 learning the information applied to chapter 2. So now we're using the chapter 2 information to solve the 3-dimension problem and 2-dimension problem. The 3.1 is talking about the velocity and acceleration vectors. So first we have to define what is the vector idea about in the 2-dimension. So if you have x, y, z in this direction, x, y, z, like here is r. This is the vector. So in that cases, if you base on the vector information r, the vector, and then that is what they call composed of ijk, ix plus j, y. Ijk is the unit vector. Just by listing this 3 vector form, then you already know that on the 3-dimension or 2-dimension, you just consider along x direction, along y direction, along z direction, and boil down to what we call motion in 1 dimension. So r equal to ix plus jy plus kz. So then velocity per se is equal to delta r delta t, or that is equal to dr dt. Okay, if you express all this out, then you find something very interesting. V, the vector, equal d dt, and then I x plus j k y plus k z, and that is equal to I dx dt plus j dy dt is called vx in the I direction plus vy in j direction, and then plus vz in k direction. So bingo, you got it. So right away, if it's 2 dimension, then you only taking care of I and J. So so that including into the 3.2 section. So if it's a 2 dimension, that's a 3 dimension now. This is a 3 dimension, 3D. And if it's 2 dimension, that is considered as 2D, then V is equal to V sub x I plus V sub y j, and that's it. Okay, so yeah, if you want to go a little bit further, we could. That means in that cases, we like to say V sub f equal to V sub using that kind of logic. F equal to R sub I plus V sub I times T plus 1.5 a t squared. So again, have this form. That is a 2 dimension. That means from 3 dimension, you can draw it down to 2 dimension. So from this on, we have to using what we call apply. Remember, any good theory, if you cannot apply, cannot use it, that's not good. You have to use them. Now, use it is number 1. So this is called projectile. So we're going to using 2 dimension projectile. Why? As I explaining in the chapter 2, that you can, even though it's a 3 dimension, by carefully rotate the axis, then you become 2 dimension. So right now, we like to take this into account, called 3.3 projectile motion. The nice thing about the PCC setup is our physics program been here for a long time, and according to some of the people say that we are around the neighborhood, we are the best. So the other teachers are the best. I'm just average. So what we like to say is this: we arrange the 31A lecture coincide with the lab, so that you'll be rest assured whatever you learn in here, very soon you're going to do the lab. In which case, the projectile motion we will do it tomorrow. Then about free fall, we will do it today. Tonight's experiment, so we will ask some volunteers to help you on the Excel. Your teacher is not so good on the Excel, okay? But TA is good in Excel, and the other person is good in Excel. So we have some kind of projectile like this. So now we draw the projectile information. So we consider a projectile like this. This is the x-axis, and here is the y-axis. So projectile is like this. So we want to even boil down a very in one dimension. So remember, this is like a vector. This velocity is a vector. So in here is a v. But we can decompose a vector into two sets. One is along the x direction, in which cases we call v sub x of x. And if this angle is theta, then that means I can say this is a v sub xi. And then in these cases, we like to say that this is v sub y. V sub y. And this is equal to v sub I times cosine theta. V sub yi, this is a very important application of math. Some of the students learn this math about in high school or junior high. We learned this trigonometry thing 2 times in Hong Kong and China. Junior high we learn once, and senior high we learn the second times, and so forth. But when we learn this, we don't know what that means. Now you're switching the focus. Hey, all the math you have, now you're going to apply. Every single one you're going to use for. So this is initial velocity. Now we have to go down to the original motion like this. This is a flow like this. This is called projectile. We have to understand the physical meaning of this. The first physical meaning is one travel along the x direction. We give a name called horizontal projection. Horizontal projection. The next one is you do this along the vertical direction, so called vertical projection. Okay, so now we like to give you more insight. When we're doing the along the horizontal direction, what's so good about this? Horizontal assume there's no air friction. This is a key component in the solving problem. So like a JPL, they said well, we should set a satellite or rocket in the sky. Okay, so they call first cut solution is without